Let's study components of a vector. Dear students, all of you know the basic meaning of component is parts. We talk about a particular vector, say x. And x vector is written as y vector plus z vector. So you can say y vector and z vector, on adding gives the vector x, so y and z are the parts of x. Or here we can say these are the components of vector x. Simply we can say when a vector is represented as a sum of two or more vectors, then all these vectors, sum of which gives the main vector, are called components of the main vector. Like say for example we are having a vector f which is written as a vector plus b vector. And say this is a vector. And if we add b vector, say this is the b vector. So a vector plus b vector, it gives this vector which is say f vector. So here we can write a vector and b vector are components of f vector. Similarly, a vector can have more than two vector components. Like say we are having e vector equals p vector plus q vector plus r vector. And say these are drawn like this is p vector. This is q vector. And this is r vector. So this our resultant e vector, that is starting point of first vector to the end point of the last vector. So e vector can be written as p plus q plus r vector. So here we can write p vector, q vector and r vector are components of e vector. A vector can have any number of components. And, as well as we can also write that a vector can have magnitude lesser than any of its components also. Or if we just have a look on this situation here, this is the magnitude of resultant vector, which is sum of a vector and b vector. And geometrically we can see that the length of a vector as well as b vector, both are more than the length of f vector. Or you can say the resultant vector has a magnitude less than both of its components. So you can just write down the point that magnitude of a component may be more than the magnitude of the main vector, of which these are the components. Which is not true in case of normal algebra. In case of vectors, we can simply say that the magnitude of a component may be more than the magnitude of the main vector. Now we'll talk about rectangular components of a vector. We just write down when there are two components of a vector, and if these are perpendicular to each other, then these are called rectangular components of the vector. Like say if we simply take up a particular vector addition analysis, like c vector equals a vector plus b vector. And see, in this situation there's a vector a. And say perpendicular to vector a is vector b. And a plus b. We are having the resultant vector c. That is starting from a to end of b. Here we can simply state a vector and b vector are rectangular components of c vector. Rectangular components are always perpendicular to each other, and a vector can have maximum, or exactly, two rectangular components. As it is forming a right-angled triangle, with the resultant vector at the diagonal, you can also relate the magnitudes of the three vectors, or you can find out the magnitude of components of vector in terms of the resultant vector. So if this angle is theta, which is the angle made by the resultant vector with vector A, so in this right-angled triangle we can find out two trigonometric ratios, sine theta and cos theta. Here you can see the value of sine theta will be equals to B by C, and cos theta can be written as A by C. That means, one rectangular component which is on the side opposite that of theta B, this can be written as C sine theta. And the other rectangular component which is on the side of this angle A, can be written as C cos theta. This is the way how we find out the two rectangular components in terms of the resultant vector and their angle made by the resultant vector with one of the vector. We can also resolve any vector in two perpendicular components. Like in normal coordinate system, say we are having x and y axis, and we are having a vector r. This vector r can be resolved into two perpendicular component. One is along x-axis, which is written as rx. Other is along y-axis, which we write as ry. In the vector, sum of rx and ry can be written as the main vector r. If this main vector r makes angle theta with the x-axis, you can simply state the vector rx as a magnitude r cos theta. In this vector ry, which is parallel to the vector which we have drawn along y-axis, there's ry. This ry can be written as r sine theta. This is again a very important terminology by which we resolve a vector into two perpendicular components along x and y axis.